All right. Hello, everyone. I'm going to talk to you about why proper data is all you need and how we're going to go beyond 9 lives. Thank you. And before we talk about how we got here, I'd like to talk about biology in general, because the biology of aging in general, because there's awesome startups that have presented here, like Shift Bioscience. There's also, being Aubrey in the audience and so on. Many people in the field understand that aging is polygenic complex, and you're not going to solve it with a monotherapy. And really, just to drill this down, and to everyone else here working on monotherapies, I want to show a t-SNE of gene ontology terms. Obviously, we have a lot more analyses than that. But what you see here is different processes that happen in biology. And you can see large clusters like that one on the top right, that's cell division. So a lot of what the cells are doing, a lot of processes are linked with cell division. But as you move away from that cluster, you have more and more differing processes like ion signaling and so on. And what we wanted to plot is what's happening if you take processes known to be linked with aging and put it on this map. And unsurprisingly, it's all over the place. So you can't really address the biology of aging without going combinatorial and broad. And that's why we're building huge databases. So I'm showing here a subset of the databases that we're looking at in terms of therapeutics, gene targets, and so on. In terms of databases that are known, maybe you guys have heard, for example, about the drug age database. It's very much an industry standard. Aubrey at LEVF also built an amazing database of mice interventions. I'm going to criticize drug age for a bit here. And to quote their paper in 2017, they took 324 publications, now it's about 1,000, but 324 publications, and they manually curated the lifespan values in C. elegans in mice and other species. And I feel like manually curating such a huge field is something that you ought to probably improve. So that's why, as Alex said, we took a lot of computational credits from AWS, from Azure, from Google Cloud. And we're using LLMs at scale to process the literature at large. And this means, like 33 million articles in PubMed alone. And that's how we came up with all of these Venn diagrams and data sets of drugs that can be repurposed, but also antibodies, other types of biologics, and therapeutics that we want to trial in combination for strictly for synergistic effects. We're not interested in additive effects. And you see here our pipeline. 2 of the leads that we have are currently in clinical trials, state supervised. Alex has shown you data from one of them per one. We also have IND enabling on several of them in preclinical studies, and we have ongoing discussions on a licensing deal with a top 5 big veterinary pharma company for the exclusive rights on PER 1 and 2. Because ultimately, what all of us here want to do is bring the research to the market. But we don't need to build the factories. We don't need to build the distribution channels or the education for the veterinarians or ultimately human doctors. So I think collaboration with big pharma is going to be key here. And as Alex said, really excited to see clinicians looking at PER 1 and seeing changes in weight and muscle mass and body condition scores with the cats. And I think we need more of this to reach the market faster so that not only can our pets live for longer, but that other people can change their minds about malleability of aging. And Aubrey is doing a lot. Adam agrees. Thank you very much for having us at the conference. It's awesome to meet so many cool startups around here. And I think, we ought to collaborate more. We are collaborating with EpiPause, which is kind of like a like a 23andMe, but for epigenetics, but for aging. And I think there's going to be a lot more startups around here that we'd love to work with. And yeah, this is our team. My co-founder and I met a long time ago. We go way back. We've also met Alina. I'm very, very lucky to to network through her with Nobel Prize winning scientists that we hope are going to join the board, and venture capital funds. We've been backed by Early Game Ventures and NIVC, which is the sister fund of LongeVC, which many of you may know. We've also received investment from Adrian, which he was a high-level executive at Novartis Animal Health, and I think we're shaping out a great team here. Our very own Anna Crucianu, a senior veterinarian specializing in geriatric felines. And with that, I'm happy to take any questions.
Thanks, Alex. Yeah, it's very valuable work. The only concern I have is I'd like you to elaborate a little more on the distinction that you're making between additive effects and synergistic effects. I'm a little nervous that you may be a little bit too hasty in going, you make a lot of false negatives that way, because, something that looks synergistic, additive on not synergistic on a log scale may look synergistic on a linear scale. Lots of things like that. And just like data set size, and statistical significance on that. I'm much more reluctant to reject things that don't look synergistic. So can you elaborate a little?
Yeah, just some background for the audience for the distinction between additive and synergistic. So additive is something where you expect, like a 5% plus a 5% effect to give you a 10% effect. Synergistic is where you'd have, for example, a 20% effect from two drugs that individually have a 5% lifespan extension. And yes, of course, additive is not bad, but it's not what we prioritize. And obviously, that you need to prioritize. There's so much that you could do in the longevity space, and there's only so much funding. And whenever we see something that has an additive effect, we either backtrack it if we have a better lead, or we try to out-license it. Obviously, we're gonna try to out-license it. Now, per one seems very nice, and obviously we think it's synergistic rather than additive, because the individual synergistic compared to the individual effects of the compounds. Yes, yeah. So in this, per one is 5 molecules. Some of them are, rather well known, and like Glynac. But per 2 is 2 molecules. We can't disclose it yet because per 1 is provisionally patented, per 2 is not. And I can privately talk about this anytime.